Sucralose is a synthetic carbohydrate-based sweetener. It is a 3-chlorinated disaccharide, means it is chemically modified from common table sugar sucrose. Sucralose is a high-intensity, non-nutritive sweetener that is approximately 600 times sweeter than sucrose. Sucralose is synthetic because, unlike sugars found in plants, it is created through a complex multi-step industrial process. Sucralose often referred to as a substitute disaccharide or a chlorinated carbohydrate because it retains the basic sugar ring structure while replacing specific atoms. Although based on a carbohydrate, human body does not recognize it as a carbohydrate. It is not metabolized for energy. Sucralose is best known commercially as Splenda and is widely used as a non-caloric sugar substitute in food and beverages.
Sucralose is a structural analog of sucrose, a disaccharide consisting of glucose and fructose subunits linked via an alpha-1,4-glycosidic bond. The molecular architecture of sucralose is derived by the selective substitution of 3 hydroxyl groups in the sucrose molecule with chlorine atoms. This modification maintains the general saccharide framework while significantly altering the chemical behavior of the compound. The transition from sucrose to sucralose involves a precise elemental shift. Sucrose contains C12H22O11, meanwhile sucralose contains C12H19Cl3O8. The formula reflects the displacement of 3 oxygen atoms and 3 hydrogen atoms, replaced by 3 chlorine atoms. This halogenation results in a higher molecular weight and increased lipophilicity compared to the parent disaccharide. The systematic IUPAC designation for sucralose is 1,6-dichloro-1,6-dioxy-beta-D-fructofuranosyl 4-chloro-4-deoxy-alpha-D-galactopyranoside. This nomenclature specifies the exact stereochemistry and the carbon positions which are at 1, 4, and 6, where the chlorination has occurred. It further identifies the inversion of the configuration at the C4 position, which technically classifies the glucose half of the molecule as a galactose.
Start with sucrose, it is first reacted to protect specific hydroxyl group, most commonly the primary alcohol, at the 6th position by converting it into an ester like sucrose 6-acetate. The acetic acid reacts with dicyclohexylcarbodiamide to form a reactive O-acylsucrate intermediate. This activated electrophile is susceptible to nucleophilic attack by alcohols and reacts with the C6-hydroxyl group with good selectivity. The solvent used for this transformation is dimethyl formamide. As a polar aprotic solvent, it is useful for promoting SN2 reactions. This prevents unwanted reaction at that site. The protected intermediate is then reacted with chlorinating agent, which is phosphorus pentachloride. Trichloroacetonitril is used as an additive in the reaction, dramatically increasing the reaction rate through an unclarified mechanism. This replaced the hydroxyl group at the 1, 4, and 6 positions with chlorine atoms. After that, it will undergo hydrolysis step where the protective ester is removed using basic methanol. The resulting crude sucralose is purified through crystallization, often using water and activated carbon to achieve food-grade purity.
The substitution of chlorine atoms yields specific physiological and sensory outcomes. First, enzymatic resistance. The presence of chlorine prevents recognition and hydrolysis by alpha-glucosidase and other digestive enzymes. The glycosidic bond remains intact throughout the gastrointestinal tract. Second, caloric profile. Due to the lack of metabolic breakdown, the molecule is classified as a non-caloric sweetener. It is excreted largely unchanged. The last one is sweetness potency. The structural changes to enhance the binding affinity to the T1R2 or T1R3 sweetness receptors, resulting in a sweetening power approximately 600 times greater than that of sucrose.
Sucralose is a synthetic carbohydrate that appears as a white to off-white crystalline and odorless powder. It is also highly soluble in water, which makes it easy to use in beverages and liquid products. Hence, its melting point is 130 degrees Celsius. One of the most important properties of sucralose is its intense sweetness. It is approximately 600 times sweeter than sucrose, meaning that only a very small quantity is required to achieve the desired level of sweetness. This high level of sweetness allows the manufacturer to significantly reduce the calories content in foods and also beverage products. Next, the chemical properties. Sucralose is very stable and it can withstand the high as well as acidic and basic conditions without decomposing. Therefore, because of this stability, sucralose does not break down easily when they are exposed to heat, acid, and bases, and making it suitable to be used in baking, cooking, unlike some other artificial sweetener that lose their sweetness when heated. Moving on, another chemical properties that need to be emphasized for sucralose is that it is not metabolized by the human digestive enzymes. This can be explained due to the presence of chlorine atoms in its structure. As a result, sucralose provides little to no calories. Because of these unique properties, sucralose is widely used in several industries. In the food industry, sucralose is commonly used in diet and sugar-free products. It is found in diet soft drinks, low-calorie juices, sugar-free desserts, yogurts, and also chewing gums. This can be reflected back to the sucralose chemical properties, where it is stable to heat and able to give advantage to the food industry. This makes it as a preferred sweetener for manufacturers who want to maintain sweetness while reducing the sugar content. In addition, sucralose is commonly used as a tabletop sweetener. It is sold under brand names such as Splenda, and it is used as a direct substitute for sugar in tea, coffee, and other beverages. Because sucralose does not significantly affect blood glucose levels, it is especially suitable for diabetic individuals and for those who want to lose weight. Sucralose is also widely used in pharmaceutical industry. Many medicines, especially liquid syrups and chewable tablets, often have unpleasant taste, so sucralose is added to improve the taste and palatability, making these medications easier to consume for children and elderly patients. Sucralose offers several health benefits, particularly when compared to regular sugar. One of the main benefits is that sucralose contains little to no calories. Since it is not fully metabolized by the body, it does not contribute to weight gain, making it useful for individuals aiming to control their body weight. Next, another important benefit is that sucralose does not significantly raise the blood glucose or insulin levels. This makes it a suitable sugar substitute for people with diabetes. Additionally, sucralose does not promote tooth decay because oral bacteria cannot ferment it to produce harmful acids. However, despite these benefits, there are some health concerns, particularly when sucralose is consumed in excessive amounts. Some studies suggest that high intake may affect the gut microbiota, which plays an important role in digestion and immune function. Other research has explored possible effects on insulin sensitivity, but the findings remain inconclusive and are still under investigation. Lastly, it also can increase cravings for sweet food since our body is used to the sweets. Overall, sucralose has been evaluated by major regulatory authorities such as Food and Drug Administration, the World Health Organization, and the European Food Safety Authorities. These organizations have concluded that sucralose is safe for human consumption when consumed within the recommended daily intake limits.
In conclusion, sucralose is an important synthetic carbohydrate created by modifying sucrose. Its unique structure makes it non-caloric, extremely sweet, and stable, leading to widespread use in food and pharmaceutical industries. When consumed within recommended limits, sucralose is considered safe and effective as a sugar substitute. That's all from us. Thank you.